Hi, I'm John Paulraj, and in this video, we will start solving question number 2 from paper 3, May 2025, time zone 1 for IB Mathematics Applications and Interpretations. Let's get started. Right, then this is question number 2, all right? The following question uses statistical tests to compare the weights of eggs in different situations. Hypothesis testing. Farmer Giles owns a chicken farm and sells eggs at the local market. He assumes that the weights of his eggs follow a normal distribution with a mean of 52.0 grams and a standard deviation of 3.7 grams. Read it very carefully, as I always say, and it's a good habit using a pencil to highlight. Okay, this question is on hypothesis testing. I think every question you need to highlight it, to make sure that you've understood and don't make any mistakes, okay? And read clearly right from every description. Don't just jump to part A. Some students I know, they think the question starts there, but the setup of the question, the background of the question, please make sure that you read that also, okay? So, and even this part is important, okay? Even this part. What is this question trying to do? They're trying to compare the weights of the eggs in different situations. So, all those small things are important, just little tips, okay? So Farmer Giles owns a chicken farm and sells eggs at the local market. He assumes that the weights of his eggs follow a normal distribution. The mean of each egg, population mean, 52 grams, and the standard deviation, population standard deviation, 3.7 grams. Giles selects 25 eggs at random. Okay, now that's key. Question says, find the probability that at least 5 of these eggs weigh at least 55 grams. At least 5 of this is very, very, very interesting. You can see what's going on. The question says that his eggs follow a normal distribution. That's the population mean is 52, standard deviation is 3.7. And, from that collection, he's selecting 25 eggs at random. And then you're finding the probability that at least 5 of those 25 that he's selected weigh at least 55. So there is a combination of normal and binomial, a very, very, very classic IB question, I must say. Let's just going. Sometimes children make a mistake in, identifying, are we doing normal here? Are we doing binomial here? But it says very clearly right at the start that, his eggs, the eggs that from his farm, the weights of the eggs, follow a normal distribution. So first what we are going to do is that we'll find the probability of an egg, that follows that for one particular egg from that whole selection that weighs less than or at least 55 grams. Okay, what is the probability? That we will find first using normal. Okay, using normal here. So I'm going to try and write all these answers here. This is question 2 and this is part A, and let's say X. Okay, let X represent the weight of the egg from Farmer Giles's farm collection. What do you say? Chicken farm. Okay, maybe that's a better word. Chicken farm. Okay, important to say that. Let X be, or maybe X represent. Okay, then we can say then X is a normal, follows a normal distribution. The mean they said in the question was 52.0, 52.0, and the standard deviation is given as 3.7. And remember, when you write down what you write here, did they say 37.0? Give me a second. Let me just check that again. 33.7. What am I reading today? 3.7. Okay, can you see that? Oh my God, this is 52.0, 3.7. Okay, pardon me. All right, 3.7. So let me change that quickly. 3.7 square. Now that is a variance that we have to write here. You obviously know that the normal, the parameters when we write is the mu, the population mean, and the variance. Okay, so 3.7 square. All right, that's X. So first what we're going to do is that we're going to find the probability then. So then the probability of X, they said at least, strictly greater than is okay. Okay, it doesn't have to be equal to, because it's normal we're looking at. At least one egg, the probability of one egg being, at least 55 grams, greater than 55. Okay, so clearly defining what is x. What is x? X is the weight of an egg, and it follows the normal distribution. We said, what is this probability? Then we can say using GDC, using the graphing display calculator. Okay, and we got to write down everything that you are going to input. Okay, because you say using GDC, but how we're using the GDC, that needs to be explained. Okay, so this might be a very straightforward question to many of you, but as I have always done in all these questions, it's better to show your working, and show your working means writing down everything. So step by step we're going to through this. I am going to share my calculator, but before that let me just, okay, this is cool, huh? This is cool. All right, so let me just insert a new problem first, and I'm going to insert a calculator page there. So problem number 2 for question number 2, and we want a normal, right? So we're just going to go through normal CDF menu, statistics. You can even do that in the probability menu, by the way, statistics and distributions, and normal CDF is what we're going to use, normal CDF. And here the lower bound is 55, all right, greater than strictly greater than 55. Upper bound can be any large number, so 10,000, 100,000, whatever. Mu, let's enter mu as 52.0, 52.0, and the sigma. Okay, so even though the notation in the question, the notation involves sigma square, the variance, when you're writing, we actually use just a sigma. Okay, so all that you entered here on the graphing calculator, this part needs to be reported, not just the answer, everything. Okay, so using GDC, I'm just going to copy down what we have. Okay, so I'm just going to write down there that, and we can even write down normal CDF, so that you are explaining to the examiner, I know how to use the calculator. Okay, small things but make a lot of big difference. Okay, so lower bound is 55, upper bound is, I've used 10,000, so just write down 10,000. Okay, and the mu is entered as 52.0, and the sigma is entered at 3.7. Why I'm saying all these things? Because even as working, you have demonstrated to the examiner that you're using normal CDF. There might have been an error, even though you wrote here. Maybe, like I've said in the previous videos also, at the time of the exam, you don't know when you're making a slight error. I wrote, do you know, a couple of minutes ago for that sigma, I wrote something like 37.0, something like that I wrote. But you know what I'm talking about, right? You can make an error. So all these things will count as working. So examiners will be compassionate, definitely. So I would suggest just make sure that you write it down here also, because you're not going to be submitting your calculator. So if you make an error there, who knows? So at least you've reported here. Now after that, you can hit the OK here, and the moment you do that, you get 0.209. Okay, 0.209. This is not the answer, by the way. This is just the probability of one egg that was that weighs at least 55. What is the question? The question basically is something more than that. The question says find the probability that at least 5, because he selects 25. Can you see that? He selects 25. Now this is where it's getting into binomial. Out of those 25 eggs, the probability that 5 of them, at least 5 of them, weigh at least 50 grams. So we just found out the first part. Second part is yet to come. That is why it is 4 points. Can you see that? Can you see that? Oh, I'm not even sharing the screen. What is going on today? All right, here we go. Let me repeat what I said. I said that we have just, this is just not the answer. I said this is just the first part. Okay, and then I said that the question says Giles selects 25 eggs at random, and then this is the 25 eggs, as we can see, 25 eggs, and out of those 25 eggs, we want 5 eggs, at least 5 eggs to be having that probability, the probability that less than at least 55. Okay, I hope that makes sense, and I highlighted that this is 4 points. This is where it turns into binomial. So we got to write down, no longer write x, huh? So those things you got to be careful, because x we've already defined as the weight. So what we're going to do now is that let y be the number of eggs weighing at least 55 grams. Did we say 55? Let me just check that again. Yes, 55 was that. So part 1, normal. Part 2, binomial. And then we can say, then y is approximated by the binomial distribution. 25 was the eggs that he chose, and the probability of one of them being at least 55 is 0.209. I hope this is clear, and writing it with a new variable equally important, because I think IB, if at all, they're very strict about notation. Okay, even in your IAs, you'll notice that mathematical communication is one of the criteria in the rubric. So it's not just for the IAs, even in the exams, develop a habit of making sure you use the correct notations. So this is a binomial, that's the normal, and then we can say, so we're looking for the probability of y being greater than or equal to, because they said at least, right? Let me look at the question. What is the question? The question said at least 5 of these eggs, at least 5. So y greater than or equal to 5 is what we're looking for. Again, when you say using GDC, remember the calculator index, whatever you write, the calculator input needs to be reported. Okay, so jumping to the calculator, menu, probability, distributions again, and binomial CDF, not PDF. Did I say? Oh, I said CDF and it came to PDF. Okay, be careful. I keep saying be careful, and then I'm the one who makes these mistakes, right? Distributions and binomial CDF. There you go. Okay, CDF, number of trials. This chart, this entry thing, copy down as it is. Okay, so number of trials, remember that's 25. Probability of success is that probability 0.209 that we found out. 209. Lower bound in this case we are going to use as 5, and upper bound, because we know that there are 25, we can write 25. Okay, in some cases you can put a number larger than 25 also, but you know that the upper bound total number of eggs is 25. So let me just copy down this as it is, okay, as we did in the earlier question also. Very good habit. Okay, in fact I often encourage my students just to do that. Okay, so I'm just going to switch back to my calculator, and I'm going to write n, and I can say binom CDF, again communicating to the examiner, you know what you're using, so that should you have entered something incorrect, okay, n is 25, the probability p is 0.209, and low bound is 5 and upper bound is 25. Get into this habit. This is a really good habit, and then you can hit enter and put down the value. Okay, so jumping to the calculator screen again and hit enter, and we say the probability is 0.622. That is the final answer for 2 part A. Okay, now 2 part B. Look at that. It says calculate the probability that the mean weight of these 25 eggs. These 25 eggs means the 25 eggs that were chosen, right? Lie within 1 gram of the population mean. It's very interesting. Part A, we had to do a combination of normal and binomial, from normal into binomial and back to normal, because you're talking about the mean weight this time. Calculate the probability that the mean weight, okay, the continuous variable you're talking about, okay, measurable quantity, okay, measurable data. Mean weight of these 25 eggs lies within 1 gram of the population mean. The population mean is 52. So literally what we're asking us in terms of notation, what we need to be careful about here, let me just come to 1B. 1B, let me just write down this is 2B, or not to be, as I said before. We're looking at X bar. Okay, we are looking at X bar. That's the mean. All right, this is the mean of all the X, okay, for all the X values, because X, remember, we define X as the weight, right? The weight of the eggs. X bar is the mean. So I'm going to write X bar, let X bar represent the mean of the 25 eggs, and we are looking at a capital X bar, okay, a random variable X bar, which is also going to be normally distributed, but this time, and the mean is going to be the same, 52, right? 52.0, the same population mean. However, means behave differently than individual weights of the eggs, okay? Individual weights of the eggs are the X's, okay? So we are looking at the X bars. And the X bars, the means, as I said, they behave differently in the sense that because during the averaging processes, they don't vary as much. So as such, we're not going to use the population standard deviation, okay? The population standard deviation is 3.7. Okay, so we're looking at the mean weight. Okay, we calculate the probability that the mean weight of these 25 eggs, it could be any sample of 25 eggs, right? He just picked up a batch of 25 eggs. So the mean weight, what is the probability that the mean weight of these 25 eggs lies within 1 gram of the population mean? 52 means we're looking at when will the probability of X bar, let me just write on that statement so that you understand what we're looking for, okay? We are looking for the probability that this X bar then is between 53 and 51. That's the probability we're looking for. We want this probability. Okay, so it's the mean of a sample of 25 eggs. What is the probability that it's going to lie between 1 gram of the population mean? The population mean being 52. Now, as I said, we're not going to use the standard deviation because that doesn't apply. You know, when you're studying the means, as I said, the means, they vary differently than actual individual eggs. This is not the individual eggs, the means that we're talking about, the mean of 25 eggs, right? Individual eggs, then we can look at the population standard deviation, but here we're looking at the mean. I hope this is clear, okay? And so what we're going to use is we are going to use something called the standard error. Standard error, okay? This is like an approximation to the standard deviation. The standard error is basically square root sigma over square root of n, okay? The sigma in this case is 3.7, and the square root of, I think n was 25, okay? So literally it is 3.7 over 5, okay? So what I'm going to write here is I'm going to write exactly that part. I'm going to write this as 3.7 over 5. And remember, whenever we write that, we write it to the square because that's the variance. Okay, that's the variance. So variance is the standard error, okay? This is not standard deviation. Maybe some of you who are interested, maybe I should do a video on standard error. What is the difference between standard and standard deviation some other day? But all I wanted you to know is that we are not going to be using the standard deviation in this case, is because we're looking at the means. The means, okay, and we want to study when is the mean weight going to lie between 1 gram of the population mean, okay? So when is the probability of X bar going to be between 51 and 53? Hope that is okay. That is why I wrote it down, okay? And the reason, as I said, we are not using the standard deviation is because that would apply only if you're looking at individual X. This is the mean of a sample of 25. And as I said, means vary slightly. They don't vary as much, okay? So we are using the standard error instead of the standard deviation. Fine. It still follows normal. Okay, it'll still follow the normal, but the normal with mu 52 and the standard error, which we're using to approximate as a as an approximation for the standard deviation. Okay, standard error is what we're using. So again, back to the calculator with these values. Let's just go there. Sometimes I forget where is the. Okay, here we go. This is distributions. Normal CDF again. All right, low bound this time 51 and upper bound is 53. Okay, and the mu, remember we are using 52.0 as before. Sigma, I know it says sigma, but we are using the standard error as an approximation. Okay, what's that word? They use a nice fancy word. It comes to my mind. I think textbook uses a different word. Yeah, whenever I remember how to say that. Okay. 3.7 divided by 5. Okay, that's actually called the standard error. It's not called the standard deviation. I think yeah, I'm not it's not coming to my mind right now. There's a nice phrase that they use, some approximation or some correction or something like that. Okay, so but basically the idea is that it is not the standard deviation. That's the main thing. The technical term is called the standard error. Some other day and maybe in some other video. I'm going to copy this thing down as it is, okay? This is basically the working. So as it is, I'm just going to copy it down. So we'll write using GDC, okay? And using GDC means we'll write down what are we using. We are using the normal CDF again, normal CDF. And we said that the low bound is 51, the upper bound is 53, the mu is 52.0, and the sigma we've entered as 3.705. Okay, here's the variance, here's the mu. Now using the GDC, the value, the probability that we're looking for comes out to be What is the probability now? This is working out to 0.823. Can you see that? 0.823. Let's just copy that thing down. This is then 0.823. So I hope this helped in understanding. I really can't remember that phrase from the textbook. When I remember it, I'll mention that, or maybe I'll mention that in the next video. But that's all the time that we have for this particular video. If you found this video useful in any way, please make sure that you like, share this video with your friend, and subscribe to my channel. And do go and visit my channel. There are several videos on my YouTube channel. Check them out. If there's any topic, if there's something like standard error you want me explained, do mention that in the comment and I will make a video for you.